I saw something funny on the way back here. I saw a license plate on a car that said ASS 57. That's ASS, and which was kind of fitting because the driver was driving like an ass. Greetings, the Astro 30 here yet again with another little short circuits volume 2 project to build here today. What we're going to look at is the FM radio with electronic tuning. Now ignore that electronic tuning part because it doesn't feature electronic tuning. It uses a standard condenser style capacitor there, variable capacitor. This kit's around about $30 odd, I think 34 from memory. And in the book there's an option to get an optional case, which I have, which is HB6032. It's a similar style case to the one that I built that super ear project in before. My soldering iron just made a sizzling noise. So there's a bit of mechanical to do here. That's if you want to install it in a case, however. But this says here, this is A88. Well, it should be actually, this is an 88 to 108 megahertz FM radio with electronic station tuning and powerful amplifier included. Small enough to fit in. Okay, small enough to fit in. Fit in what? Okay, anyway, kit includes PCB tuning gang and electronic components. Kit requires a 9-volt battery. I've got one of those left. The instruction booklet or instruction sheet, which you can buy separately, and optional the HB6032 case, which I just described a second ago. So over on page 128, it's actually called a personal FM radio. Here's all the information about the project, board overlay and close up of the PCB, etc. Over on the page how it works, and just out of frame here at the bottom, basically information on how to fit it into the case. It's awfully hard trying to work around this tripod, but I do my best. So on page 129, here's the schematic, and we won't spend too long on it because it's basically very simple. It's using the classic Philips TDA 7000 FM superheterodyne chip, radio on a chip basically. Which has been around since the late 70s. It's been discontinued, but you can actually find some from Chinese manufacturers. They're knockoffs, but they do still work. And we're using an LM386N over here to power some headphones. Now, like a lot of their other projects, the interesting part is they're using the switch contacts of the headphone socket to switch up the negative battery rail up to this PNP transistor here, to allow the positive rail to be powered to the rest of the circuit when the headphones are plugged in. As soon as you unplug them, the base drive disappears from here, turning the circuit off, so it saves power. The other interesting thing over here is this little miniature tuning gang, how they've got that configured. You basically see they've got two capacitors back to back here, or in series. Now, inside the tuning gang condenser itself, it's two capacitors. Others are 4, but they're using 2 in this case. What they're doing is they're trying to reduce the capacitance of the variable capacitor by wiring it in series. So if you wire 2 capacitors in series, they will divide with each other. So if they were the same value, say 160 picofarad for instance, well, if you got another 160 picofarad in series with it, the overall capacitance would be 80 picofarad. And they've also got this 27 picofarad capacitor in parallel with the first, so that's also stepping the capacitance up from whatever the capacitance of the tuning capacitor is. Now, they don't use any interstage transformers like variable transformer slug things that you normally find in FM radios to adjust the IF stages, because it's all done with these capacitance values. So, and this directly comes from the Philips data sheet on this particular IC, so there's nothing really to it. It's what you'd call, oh I don't know, the FM radio for dummies. Just saying. Anyhow, let's open the kit and see what we've got. So on the back it just says, you know, the book's in the series. So we open the package. We'll dispose of that because that's crap about the book. Now here's the bag of components. Our battery clip, the LM386, the TDA 7000, which looks like an actual real one. The ones I've got from China look a little bit different than that. There might be a new manufacturer of that. The tuning capacitor is somewhere. They're using a miniature 9mm potentiometer for the 50k volume pot, which is nice. You can't see the tuning condenser offhand. Oh, there it is, buried under here. Yes, that's the parts. Here's the circuit board. It's up to their general standards. This piece of wire is for the antenna. This should be about 1 meter long, so we use that for the antenna and nothing else. Got what looks like 3 PCB pins to install, so it's not that complicated. Now, they say this just fits inside this case, so what we need to do is just verify as well as rectify to see whether or not that is true. It should be. That's what the information in the book says and on the front of the kit. Yeah, these panels are going to be fun to drill. I might actually make my own panels out of aluminium. It might be a lot easier. Anyhow, those are the screws for the case. That's the lid. That's the top, so that's the one you'd screw the circuit board to. Now, I can see right away that it doesn't fit. It's slightly too wide. So I might have to get creative with a Dremel, because I don't really, well actually I could take a little bit off of the edge of this side of the circuit board because there's no traces here. This is the one of the inductors, this trace here. That's L1 on the circuit diagram. As you can see, it's actually a copper trace, but it's been routed in such a way that it forms an inductance, and that's not adjustable. There's a second inductor, L2, which is adjustable. So now I'm just trying to figure out, because this is what you should always do first before assembling something, is to see if the thing is even going to fit. And it's not going to fit. I've probably got all of about 1mm too much on this side of the board. And I can't see whether or not those screw holes line up. So, they do there. So what I need to do is probably take a file, and I'll file off the edge of this board a bit. Try and keep it as neat as possible, just to see if I can get it to fit in the case. On this side. This is why it's always handy to have files, because, yeah, the screw holes will line up. I need to hit the tripod, bring that one down a bit. Now it doesn't really matter if it looks a little bit wonky, as long as it fits in there nice and snug but not tight. So that's that there. That board will now fit in there just nicely. So keep that in mind. You may have to do a little bit of manual massaging, but those screw holes will still line up, and if I have to, I will increase the size of these holes slightly just to make things fit a little bit better. Now they've actually included a kit, a tuning gang and knob kit that you can buy from JCar anyway. There's the catalogue number RV5728. It tells you on the label anyway what it is. It is a 60 picofarad to 160 picofarad. So my original statement of saying that the capacitance was 160 picofarad would have been correct. So let's stick it on the meter, on the multimeter here, on the capacitance range, which is there. Nanofarad. I don't know if this does picofarad or not, but we'll soon find out. So what I need is a lead, a jumper lead here, so I can connect the ground up without having to touch two probes at the same time. So that can sit, well, it can try and sit. Really? Okay, so what have we got? We've got apparently 0.3 nanofarad. Actually, I might take that cap off. Might get another jumper lead actually. Alright, so 0.28 nanofarad, and touching even just touching the wires is interfering with the reading. So even touching the capacitor itself does. So we increase it, well, it actually decreased. So we're at 0.15 nanofarad. Okay, so we're going, I'll say 0.14. So the minimum was 0.14 nanofarad. Maximum is about 0.28. Now for capacitor 2. If I can get the bloody thing disconnected. That looks like it's a lot lower than the other ones. That's 0.2. About the same at the minimum, so it's the gains are even, we'll say, even though the other one's 0.28 versus 0.20. To get nanofarad, you're dividing the picofarads by 1,000, so you would multiply this reading by 1,000, which means this decimal point would move from the left to the very far right. So we're looking at roughly 156 picofarad. That's at the low end. That's fully clockwise, so that's the lowest capacitance. The highest capacitance is 214 picofarad. And conversely, on the first capacitor, we're looking at closer to 300 picofarad at fully anti-clockwise, highest capacitance. And again, lowest capacitance of 150 picofarad. Isn't that exciting? Okay, the first point of assembly here is to lose shit on the floor. The first point of assembly here is there's this link wire to install, but they didn't supply you with any means to do that. So I'm just using this 0.75, I think it is, or 0.71 millimeter hookup wire, tin copper wire, whatever you want to call it. And I'm just going to have dropsies today. Cut off a piece that I need for that, put the rest away, and find what I did with my pliers. And just bend that in place. And construction, as usual, starts with the lower profile components first, such as the resistors, diodes, and PCB pins next would be on the agenda. It would have been nice if they'd have supplied an IC socket for the IC, just in case you bugger it. I'm not going to use any IC sockets. I mean, you should be able to have enough soldering experience to solder to ICs without damaging them. Just saying. It does take a little bit of practice, and it's the amount of dwell time that you give to said IC or component is what is key. 3 seconds is usually the general rule, and most data sheets for most ICs tell you dwell time no longer than 3 seconds, and that's per pin. So that's the link wire in. That's special. So there's only 3 PCB pins. 2 would be for the battery, and the other one would be probably for the antenna, if I could even pick the damn things up. Yep, there's one there, and one there for the 9-volt battery clip, and this final one goes there. That's for the antenna. That's the resistors all soldered in. I can trim the leads off and then move on to the next part, which is going to be the ceramic green cap capacitors as well. Yeah, there's a green cap in there. But there is a 1N4004 rectifier diode, which is across the positive, in series with the positive rail. That's just so it you don't connect the battery around the wrong way and damage anything. So I'll grab that out the bag and I'll install him next because it's convenient. Right, so moving on to capacitors. I hope people actually enjoy these longish videos. I mean, I don't set out initially to make them super long, they just end up that way. Okay, so that's all the ceramic capacitors installed and it's starting to look like something. Now there's a 3 100N or 0.1 microfarad capacitors, one there, and I can't see the other one offhand, it's around somewhere. Anyway, they're using monolithic style capacitors, these I don't know what you'd call the look of them, but yeah, anyway. So they just, one goes in there. And I can see the second one, but I can't see the third one. I've got them 2 in. I can see where a 10 nanofarad goes. I can see where the transistor goes. There's the second one. I, for the life of me, cannot see where the third 100... Oh, there it is, hiding. Right there. Okay, turn off the excess. Now, I might as well mount this potentiometer because it's just conveniently handy. So I'll put that in there like that. That's our volume pot. And there's nothing to trim on this, so we leave that alone. Well, that's a bit crooked, but we can bend it a little. Just don't over bend it too much. They give us the hardware, mounting hardware, the nut and the washer. So I'm going to just place them on the potentiometer so we don't lose them, because that has happened before. I have got spares, but still. Next, I might mount the jack for the headphones, which is in this other bag here. So here's the phones jack. That's going to mount there. It's already got its screw on it, its nut. Make sure that the leads are straight. That's why it won't go on the board if they're not straight. You won't get a clear shot otherwise. It's quite a tight fit. That's what she said. Anyway, let's solder this in. What's annoying about this book is if you've got to do some mechanical, that's a bit bad, if you've got to do some mechanical work like cutting out a case, they don't give you much in the way of drilling guides or, you know, measurements so you can actually do it. You've got to measure it yourself, which is annoying. It'd be nice that if it was in the printed material, what the distance between this pot and this is, and the height, etc., and whereabouts in the case, that you've actually got to cut a slot to accept the thumb wheel that comes with the capacitor. Yeah, would be nice, but they don't. So I'm going to mount this PN200 PNP transistor because that's just conveniently handy. So it just goes in there. And the end of my soldering iron stand, which is hot. Ha 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 ha. I can't get it back in there. There we go. Had to come out. It wasn't really that hot. Okay, but it was hot enough. That's the transistor mounted in. Now I'm going to wait to do the two ICs semi last. I'm going to do the coil last, but I'm going to do the ICs after I've done the tuning capacitor. Now, it says spindle on track side. That means this spindle has to face downwards. So the capacitor actually mounts on the component side, which is, well, kind of obvious really when you think about it. But we'll put them in their respective holes like that, and I'll get the two screws that screw the thing together from the bottom to mount the capacitor, because I'm going to screw the capacitor in first before soldering it, so we're not stressing anything. So that's one screw started. Second screw started. Okay, and so now we can just do them up. This video file itself's been going for the last 30 minutes, so that's how long it's taken to get basically from the resistors, capacitors, and to this point. It's only about half an hour. And plus I've been talking as well, so that is going to make a difference. So I'm just going to make sure that those, yeah, it's fairly bad routing, but anyway, or bad drilling. I suppose I think they know what they're doing. Now this is the reason why I want to do the capacitor first, is because they may take a little bit more heat and solder in order to get them to fill in the large hole. But don't sit here with the soldering iron on all day, because the other side of this is only plastic and it will melt it. So we just trim off the excess. You could have bent them over flush with the board and then soldered it, so you didn't have to trim them. But well, I didn't. I couldn't think of where I was going with that. Okay, so that leaves, this is a knob, does it fit? No. That leaves the ICs, so the LM386, which goes there. So make sure to put it in with the notch facing the correct way. I need a small implement. There we go. once that's started anyway. Solder one pin. See, that only took like about a second. Just making sure that it's reasonably flat. I believe it is. And then I can solder the rest. Orientation, as in the direction you put these ICs in, is important, because if you put it in the wrong way around, you will damage it. So now for the TDA 7000, which these aren't really that static sensitive, so you can handle them. I suppose the easiest way would be to just slightly bend all the pins in a bit. Yes, I'm putting my fingers all over it. It's not going to kill it. Don't leave any hate comments below. So line the notches up to the notch on the board. Try and line the leads up as well without bending any over. Get my implement in here. There we go. The IC is now inserted. So I can start with one pin. Okay. Make sure it's still flush. Yeah, it is. Might just do the opposite side for luck. There we go. So that's all it takes. 1.5 seconds. It helps if the pads that you're soldering to are templated too, as these are, which means you're putting very little heat into the IC, and I'm using an ESD safe soldering iron as well, so I'm not putting any static into it. Not that static would really kill this. These ICs, believe it or not, are very hard to destroy, unless of course you reverse the polarity. Alright, so that is basically the construction completed, apart from this inductor, which is what we're going to have to do next. And it comes in several parts. Well, in this case it only comes in two. There is supposed to be a former base, but there isn't one. So we're just left with this, which doesn't even fit in the board. Yeah, that doesn't even fit in the board. There's supposed to be a base that sits into, but they didn't supply one. Well, that was nice of you. So, I don't know, how are you supposed to correct for that? Brilliant. Means I'm going to have to drill that hole out a little bit bigger to fit this in, because it won't at the moment. But it comes with a slug and a former, and it doesn't really matter which way around you put the slug, because there's a notch in both ends to insert a tool to adjust it. So I'm just going to screw that in to the former. So the inductor goes through this 10 nanofarad capacitor to pin 4. 1, 2, 3, 4 over there, so that should route back up that way somewhere. So it'd be I would have thought it would have been that capacitor. Pin 4 is there. Now it goes through that 10 nanofarad capacitor there, so that little ceramic, so that goes to this part. I need to mark it with something. So this is one side of the coil, and the other side just goes to pin 6, which is 1, 2, 3, 4, 5, 6 there, so it's on that one. So I need to put my coil in those two points diametrically opposite. So there's the hole, which I'm going to have to enlarge because the shaft doesn't fit through. That's one mounting point, that's going through the 10 nanofarad capacitor to, well, part of it is 10 nanofarad capacitor to pin 4. That one's going through pin 6. There's 1, 2, 3, 4, 5, 6. And yeah, it also mounts through pin 1, pin 3, so that's okay. Mounts through 3 different capacitors of the IC. This doesn't actually correlate with the schematic. I've just noticed that one side of this tuning condenser is connected directly to the positive rail, or the positive 9 volt. On the schematic, it's actually connected to ground. So this would be the side that should be connected to ground. But for some reason, they've connected it to positive. Now, for all intents and purposes, does it matter? Probably not, but it doesn't correlate with the schematic, so the schematic is wrong. This board, which doesn't have a revision number on it, is well, it's the same as the one in the book, the overlay, and it didn't change much from the original etched circuit board they used for prototyping. That's the same, but they've put the tuning condenser to the positive rail instead of the negative. Well, whatever. Moving on to the inductor coil. Okay, so first it'd be good to know what size I need to drill the hole out to. So I'll start with 5mm. That looks like a good candidate. Probably slightly bigger than that. I'd say 5.5. I shouldn't have to do this, but yeah, it's freaking annoying, because you do want to have that in there in such a way that it's not going to move around. Right, the instructions say you need a piece of 0.5mm enamel copper wire, and the idea is you need to wind 2 turns around the former, and it doesn't really matter which direction you wind it in, I don't think. And then the leads have to be bent at right angles bared so they fit through the holes. So what I'll do is I'll put it on there, and that's half a turn. So that's 1 full turn there. And 2 turns would be when we come back to where we started. So both of these ends of wire meet up with each other would be 2 turns. And what I'll do to make sure it's nice and tight, it stops moving around on the former, is to make sure that I've actually got it pulled tight. Now, they need to be bent over to go into the PCB holes. PCB holes. So I'll just bend them sort of like that. And we have to remove the enamel off of the wire here. So I usually just scrape it with a knife. And there. Right, so I might actually, well, seeing as it comes off the former, I might take it off for a second, get this to go in there, so we're already started. Like so. Then put our coil on, where it goes, which is there and there, I believe. I'll turn it over and check in a sec. Nope. There and there. Is that one right? Yes and yes. Okay, so I can pull that side down, pull that side down. We want to get that down as low to the former as possible. By pulling on it, it'll also tighten the coil around the former. Now that looks alright. So hopefully that will solder in now. That one seemed to take okay. That one didn't yet. Looks like it has now. I'll just fill in all those solder holes there. So that should be soldered in, which it looks like it is. Maybe not so much that end. It's a little bit more heat. I think it is. I'll find out when I cut it off. So looks alright. I'll just make sure that we are soldered in. Looks like we are now. So that's the coil mounted. So what we need to do now is I need to put a drop of hot glue on the underside and on the top side there just to stop it from moving around. Okay, so the hot glue gun is ready. So I'll just put a blob of hot glue, hot snot around the former, trying not to get it on where the slug is, because then you won't be able to turn it. So it's just, doesn't matter how much you use here, it's relatively cheap. I can't quite get into that corner, so I'll turn him over, apply some hot snot just around the edge, trying not to get it down in the threads where the slug needs to turn, because that might get a little bit messy. But that should be all that is required for that. I shouldn't need to do any more than that. So now I'm going to mount, or solder on, the supply battery clip, so we can get some power going to it. Because before I put it in the case, I'm going to test it. So I'm not going to shorten these leads just yet. I might have to when it goes in the case, but for now I'm going to just solder what I need to get it going and then worry about that later. And finally I'm going to take my piece of black wire here, which is 1 meter long, for the antenna, and solder that where it goes, because FM radio does need an antenna, but it is kind of helpful if the antenna was directional. This is not. Okay. So before I actually solder this on, I know it's going to go out a hole in one of the panels, so I'm going to tie a knot in the wire so that it doesn't come back out the hole when it finally goes in there. Doesn't matter how long it is, but so that can be soldered in permanently like that, and that can just rest over the back of the tripod here somewhere. I'm going to test this. I'm going to leave it in this mounted device, but what I should do now is put on my thumb wheel so I've got something to tune it with. So it's notched so you can't get it wrong, doesn't matter which way around it goes. turn it back over. Now, without playing with any of the adjustments yet, I'm going to hook it up to the speaker that's sitting on the desk here. This LM386 should have enough power to drive that. Doesn't have to specifically be headphones. So I'm going to use this 3.5 to RCA plug lead here. I'll plug one end into the circuit board. I'll be very careful with that now, not to bump it or anything. Okay, and I've got the jumper leads hooked to the other end, to the speaker. So now I'll plug the battery in, it'll probably make a popping noise, which it did not. Well, I can't hear anything. There's no output to the speaker. Alright. Idiot. It helps to actually solder that pin in, which I believe is kind of important. That's part of the socket. I was getting no output, couldn't figure out why. I was using headphones a second ago just to see if I could hear anything, but nothing was happening. So I'll do that again. Oh, now I can hear output. How about that? Alright, let's hook that up back to a speaker, wherever the enemy lead went. Alright, so as you see, I've got a little driver on the desk here. It is driving it, it's just not very loud. Right, well the circuit is working. It's actually going into headphones at the moment. I need to put it through an amplifier so you guys can hear it. Alright, so I've hooked up the little Class A amplifier, Project 9. Really? Alright, well it won't work into an amplifier. Must be a DC offset on the output, so... Well, anyway, it's working. I don't know if the camera picked that up, but yeah, it's working. So now I can move on to the next stage, which is putting it in the case and actually, well, seeing if its range is correct. That'll be the next step, but I'm going to take a break for an hour or so and then we'll come back. So I was messing about and I realised that I could actually get an output into the interface, not an amplifier. It could be because the impedance is too high.
In India later this month, for the rain.
Yeah, started together in summer. Instead of playing cricket, made beats and bars.
And
mevsimini karşılayacağız. SBS Radyosu Türk.
Alright, so the next thing to do would be to mount the PCB into the case. Now, the book says it will fit in there, but you need to add 4 spacers, like M3 nuts, and use some self-tapping screws. So, the question is where to actually mark and cut the slot for the thing, because it doesn't actually give you any real guide here, but I'm going to say that the center is going to be there. So because that just fits in there nicely. So the center of the knob is there somewhere. So we'd have to cut a slot which, judging by the amount sticking out there, doesn't have to be very wide. So I'm going to say slot about that wide should do. Doesn't have to be terribly accurate, but it's very close to the edge of the case. So what we have to do is, well, we're going to have to like cut it with my little Dremel tool thing. Cut the slot out. It's just like put the disc on it and put it in. The thickness of this, well, yeah, I would say just above the line. The line can always be erased, but yeah, let's have a look at this. So this is all pretty much guesswork at this stage. So I'll turn that around a bit. So I'm going to go just above there. Now, I don't know how well that's going to work, or how well we did here, but I'll just get off all this crap. Let's see if at least the shaft fits through the hole. Yeah, right. So, I'll get all these burrs off. I can clean it up with a bit of sandpaper, that's not a great big deal, but the actual width of the shaft's got to fit through it as well, keep that in mind. Which is, yep, not going to happen yet. So let's see. I'm getting close. Just a little bit of mechanical, which is a pain in the arse. We've got to get that to fit through and turn. So it's still not wide enough. It's long enough, but it's not high enough. So a little bit more manual massaging. bit of damage to the bottom of the case there. It's neither here nor there. I need to get these burrs out of here. That's a bit better. Now, let's see if it fits in there properly. That fits a bit better. Yes. Now, I don't know if M3 nuts are going to do the job. I can't really go any lower than that. Now, this may seem kind of destructive. I've taken the wheel, I've drilled a 6mm hole right through, and I've brought that shaft all the way down as far as I want to get it, and I still get a nice reasonable snug fit on the capacitor. So as long as that still works, that's fine, because forget following the book, it's useless. You will never get this to fit with the battery in there the way they tell you to do it. No way whatsoever. So I think I'm going to take a little bit more off that wheel, just a smidge. So I want to try and get this board flush down with the mounting eyelets on the case here. Well, at least that's the plan anyway. Don't want to take this too far to the circuit board. Now, you may be saying to yourself, why did you drill a hole through it? Well, I didn't mean to actually go all the way through. Now that's a little bit too low. Just need to bring him up a bit so that it turns, preferably turns. And I will solve the issue of making it stay there in a minute. I just want to get it so it'll turn. I also want to get it so it will mount flush with the base of the thing here, which is about there, so I can actually do it. So yeah, that's pretty much good there. So I'm going to leave the thumb wheel like that. May seem strange to some of you, but I'm going to put a dab of hot glue down the center of here, or at least try to, and then try and put the screw in. I've got the screw, but I need to obviously put a washer on the outside to cover that hole, because I reckon I can still get the screw in there if I try. Yeah, the screw will still do up, so there's plenty of meat there, because there was no way I was going to get the bloody battery to fit with the case on top. It just wasn't going to happen. So I'll move that to the side. I may want to... No, I'll leave that alone. Okay, hot glue time. I just realised that the screw may come into contact with the case, so I'm just going to fill that cavity with hot glue, and then the excess on top I will God, this stuff's a pain in the ass. I'll just cut off with a knife. It's not real great big of a deal. It's just there to hold it. I mean, it's not there to do any other purpose. That should be right as it is. Yep. Yeah, it is going to turn on itself. That'll be right. Fuck. This was a complete disaster, I'm telling you. Absolute complete disaster. Because I don't know if I'm even going to get the screw in there now. I don't think hot glue is going to work too well, to be honest. I don't have any super glue either. This is just, I mean, whoever designed this fucking idea is a complete retard, because yeah, it's just going to spin. So not going to worry about it. I can fuck off too. And these two bits can also fuck off. So that can come off of there. That's useless. Because I just happen to have a spare one here that goes with another capacitor, about the same size. So I'll just use this one instead. I'll achieve the same thing. So at least it's complete. So now it turns, so that's alright. That's fucked. Anyway, I've given up on the case idea. I've just mounted some standoffs to hold it up off the desk a bit. I'll come up with a different idea of mounting it in something. I'm currently testing it. I've moved this coil in a bit and trimmed these capacitors a bit. These are awfully stiff to move, so I've done a little bit of marring to the screw heads, but that's alright. The TDA 7000 is still exhibiting the same effects as when I played with my own design, although it would go crick, crick, crick through the music, because it just cannot precisely tune correctly. These thumb wheels are a pain in the ass on any radio, but it's working. I've pulled it off the desk about 3 times and sworn my head off, and yes, I cracked the shits. I threw the case across the room. That was a waste of about $6, I think it was. Can't use it, there's a hole in it now. Oh well, who cares. Anyway, don't bother trying to fit it into the case. You won't. No matter how hard you try, you just won't. It's a waste of time. So anyway, I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30, going to go have a beer now, and I'll see you later.